Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Let me introduce myself. My name is Theorem with name 220291110. I'm from Mathematics Education Program. In this section, I will explain about the Chinese remainder theorem. Appetizer problem. Brilliant Duck in Bertrand Carroll's fiction book Methuen was indeed brilliant. She devised a quick way of counting her ducklings, which was basically a residue evaluation process after division or separately by 5, 3, and 11. She knew that when counted by 5s, 2 ducklings remained. When counted by 3s, 2 ducklings remained. When counted by 11s, 3 ducklings remained. What is the smallest possible number of ducklings she has? Thinking might have revealed that the number of ducklings is given by the number which occurs in each of the following arithmetic sequences. The smallest common number 47 can be found by developing those sequences a little, and occurs when P is 9, Q is 15, and R is 4. Therefore, Brilliant Duck has 47 ducklings. The Chinese remainder theorem. Suppose we wish to find a number x which leaves a remainder of R1 when divided by D1, a remainder of R2 when divided by D2 until and a remainder of Rn when divided by Dn, where no two of the divisors D1, D2 until Dn have any factors in common. Let D is equals to D1 times D2 until times Dn, and yi is D over Di. Now, if we can find numbers ai such that, then the solution to our problem is x is equals to a1 times y1 times r1 plus a2 times y2 times r2 plus blah 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 plus an times yn times rn is equals to sigma of ai times yi times ri with I from 1 until n. Solution of appetizer problem. D is D1 times D2 times D3 is equals to 5 times 3 times 11. This is 165. Yi is D over Di. Y1 is 165 over 5 is equals to 33, while Y2 is 165 over 3 is equals to 55. Y3 is 165 over 11 is equals to 15. It remains to find a1 such that 33 a1 minus 1 is divisible by 5, a2 such that 55 a2 minus 1 is divisible by 3, and a3 such that 15 a3 minus 1 is divisible by 11. It should be easy to see that a1 is 2, a2 is 1, and a3 is 3, give the desired result. X is equals to sigma of ai, yi, ri with I from 1 until n is equals to a1 times y1 times r1 plus a2 times y2 times r2 plus a3 times y3 times r3 is equals to 2 times 33 times 2 plus 1 times 55 times 2 plus 3 times 15 times 3 is equal to 132 plus 110 plus 135 is equals to 377. Now, any number of the form 377 plus minus 165k is a solution. However, to get the smallest possible solution, we set k is 2 to obtain 377 minus 330 is equal to 47 as before. The working could be neatly laid out in tabular form as shown below. Well, that is for explain about the Chinese remainder theorem from me. Thank you for attention. Assalamualaikum warahmatullahi wabarakatuh.